So now, I made this demonstration circuit with the 4001 integrated circuit. They get damaged by shock easy, so I'm going to make sure and discharge myself, touching the negative supply. And we have a Trimpot here. So both inputs have to be low for the output to be high. So the red LED is not going to be very bright, 1000 ohm resistor, because these integrated circuits can't provide a lot of power. But in any case, if one input or the other or both are high, then the output goes low. So the output is only high if all inputs are low. Pressing the switch also sets the input high. A separate input, there's two inputs for each of these NOR gates right there. And also I have a light dependent resistor in parallel with the switch basically. So if I get light on the light dependent resistor voltage divider, that raises the voltage enough to give a high input, and thus we get a low output. So now we'll look at a schematic diagram I made for a demonstration circuit for the 4001 series integrated circuit. It may say CD 4001, but in any case, the output, it's a NOR gate. This is OR right there with the dot to the right. That makes it a NOR. Both inputs have to be low in order for the output to be high. That's the main thing. So we got to keep the Trimpot voltage low enough voltage to A for the output to be high. We raise the Trimpot voltage, then the output is going to be low, high, low, no matter what. And then, so we set it back low. We got A right there. Again, we have a pull down resistor that is going to try to keep a low input there, and thus that can set the output high. But first off, we have a switch. Let's cover that first. I can close the switch, give a high input. That makes sure the output is low no matter what. High input, low output. We have a backup though, even if I'm not pressing the switch. A bright enough light will give a high input to A, and thus make sure the output is low. So now, when it comes to the 4001 quad 2 input NOR gate, so there's 4 NOR gates. Each one of them has 2 inputs. The outputs are in the middle, which is kind of interesting there. Positive supply to the top right pin, and then negative supply to the bottom left pin right there. And so there you can see we got top right positive supply, and then bottom left negative supply. We're only using one of the NOR gates, that one right there. So wherever we have a NOR gate we're not using, I tied the inputs to the positive supply so that the outputs don't oscillate and mess things up. That's about all they do. So we're using this NOR gate up here. I got the Trimpot coming to one input, number 2 down there, second one down, and then a switch coming to the other input, the top one there. But there's a pull down resistor to work with the switch, but also makes a voltage divider. It's a 3000 ohm resistor with the light dependent resistor. So a bright enough light gives a high input. So now we come back to the 4001 series integrated circuit, which is 4 2-input NOR gates in there. So each NOR gate right there, I got this from a data sheet a long time ago, but looks like they can provide probably about 0.88 milliamps of current sinking or sourcing, and therefore we don't have much current to work with. That's why in my demo circuit I put a 1000 ohm resistor for the red LED. The resistors probably aren't even limiting current as much as the output will. You do get higher currents with higher voltage though. You can if you want. Now the thing with this is if you have 5 volts at the supply, which I normally use, that means you can actually get basically 5 volts out. But you know, load's going to throw that off. That's why current's limited. And then if you have a low output, you can probably get really close to 0 volts right there. So you got the full voltage range at the output as long as you don't have a load. So now, the 4001 series integrated circuit, based on the diagram I just looked at, says that basically we should be able to get the full supply voltage, both positive and negative. So this is 5 volt supply. We would expect 5 volts there, but we have a load, so I'm pretty sure that's throwing it off. It says it can only provide about 0.88 milliamps of current. And there, we try to go to ground. It's not quite making it to ground. It's about 0.5 volts more. But again, probably because we are asking for more current. I could also press the switch or use a bright light to force the output low because it's a NOR gate. So what I'm going to do is pluck both LEDs right there. The red one right now is holding it down. And there, you can see we got basically 5 volts. That's probably the full supply voltage right there. And now we will set one of the inputs high so that the output goes low. And we do have a connection to ground. So this is a rail-to-rail integrated circuit. So now recently we've been looking at the NOR gate a lot. This is a true table. This lets you know what the output's going to be based on what the inputs are. We got two inputs with the integrated circuit we were using, the 4001. And so as we saw, we need both inputs low. We need close to ground, less than half of the supply voltage. And then we got a high output, close to the full supply voltage, at least more than half. And then if we have one input, another input, or both inputs high, then the output's going to be low. So basically the output's low unless both inputs are low. Then the output will be high. That's the main thing. And the 4001 series integrated circuit, I used LEDs to indicate when it was high or low. The 4001 though cannot provide a lot of power. So even though the output wants to be, for this particular one, exactly ground, the load is going to throw it off when the output is low. And then same when it wants to be high. It wants to be 5 volts, but the load is going to throw it off a little.